Hello, everyone. My name is Kaushik Saha. Thank you for having me in your course and giving me the opportunity to tell you briefly about packaging program here at Cal Poly, how you can do a packaging minor as you pursue your degree in food science, along with a brief tour of our packaging labs, what it has to offer to you from a learning point of view. First, a little bit about myself. I'll go over a little bit about myself, my education, teaching experience, and professional experience. And then in our guest lecture, we will go over Cal Poly packaging. We'll watch some videos related to that, some videos related to packaging labs, and eventually I'll let you know how you can pursue a packaging minor and how it can benefit you if you were to pursue a packaging minor as a food science student. So let's start off with a little bit about myself. I received a PhD in packaging from Michigan State University. Um, and prior to that, I earned two master's degree. One of my masters was in packaging, which was in the area of food packaging, and my second master's was in the area of food science. I mostly worked in the area of lipid chemistry, and my first degree, which was my bachelor's degree, it was in agriculture science. So essentially, I covered most of the food supply chain across different levels. And my terminal degree, which was in again in packaging, had to do with distribution. It had to do with how distribution can have an effect on fresh cut fruits. So I came here to Cal Poly in 2010 after completing my PhD, and since then I've taught several courses, close to five different courses. But of late, I've been teaching three undergraduate course and two graduate level course. At the undergraduate level, I teach packaging fundamentals, packaging quality assessment, and senior projects. And at graduate level, I teach packaging materials and quality evaluation of packaged products. Now, to give you an idea of Cal Poly packaging and also packaging education over North America, I'm going to share a slide with you here. Here is the map of US. And you will notice that most of the programs which offer a four-year degree program are in the East Coast. And that's where historically the packaging discipline as education discipline started, and it first started at Michigan State, and then it slowly spread to some of these other universities. However, on the West Coast, there are two universities. One is at San Jose State University, which offers a bachelor's in packaging, and us, which at Cal Poly, we offer a bachelor's in industrial technology and packaging with a concentration in packaging. And as part of this program, Cal Poly packaging program, we also offer packaging minor, which is only which is open to all Cal Poly students except for students in Bachelor's of Industrial Technology and Packaging. And how you can benefit from this, we will go over that in a little bit towards the end of the guest lecture. So here, let's watch a video here. The video is related to give you an understanding of what Cal Poly packaging program is. The person that you see here on this video is Dr. Jay Singh. He's the director of Cal Poly packaging. He's been here for a relatively long time. And in this video, you will also see some of the professors who you may take classes with if you were to do some of the packaging courses.
People don't usually understand how big the packaging industry is and how sought after people who have the knowledge and experience in the industry are.
So there's a lot of demand for trained packaging professionals to go get jobs or be immersed in improving their industries.
Cal Poly's packaging program is the most comprehensive packaging program in the country and probably the world.
I think what makes the program so unique is that it's housed in a business school. So they get to understand end-to-end the packaging development process from a business perspective.
Located between San Francisco and LA, if we look at the region as a whole, you have fresh produce, which is very dominating. You have pharmaceutical, you have medical devices. If you are looking for opportunities, if you are looking for something different, something unique, it's right here.
The Learn by Doing mantra which we have in our university is pretty much in every course that we teach, and the lab activities are designed around actual on-the-job practices.
They're going to be working on projects where they're going to be doing from concept development to commercialization of the product.
They can learn the theory, they can learn the chemistry, they can learn SolidWorks, they can learn designing, but at the end of the day, they are producing something which is real, which can be put on shelf.
Our rapid prototyping and design labs train students to develop a concept and bring it to life through prototype products and packages. Our materials testing lab allows us to validate material specifications for paper or plastic and evaluate the strength of packaging components. Our plastics processing lab is where we convert resin into most of the commonly used packaging forms, such as film, clamshells, and bottles. Our packaging dynamics lab simulates the physical distribution environment experienced by a product package system, whether it's a small box mailed domestically or a container shipped overseas.
When I went and actually did an internship, I already had so much experience with all the programs, technical programs, and lab equipment, trop testers, vibration tables, cutting tables, everything. We've gotten to use and actually not just use once and see once in a lab, but use over and over again and feel comfortable around them.
The classroom environment we provide to our students beyond these technical aspects also prepares them to pitch, market, and launch new products.
Packaging value chains relate to this holistic approach to packaging. So packaging has the opportunity to provide value at every step in the supply chain.
The Center for Packaging Value Chain is going to provide a very rich environment and space for actually students and faculty to interact and be able to come up with really great ideas and be able to develop them and commercialize them.
We're training students to be the future of the packaging industry, and they can add value to companies much faster with the more experience they have with better labs and more class time, more face-to-face time with machinery. You're just investing in your company's future.
I'm motivated to make it better because we are all passionate about it. The entire team is very passionate. We are not satisfied with our success. We want to keep improving it because at the end of the day, we know that we have a lot more to give back to our students as well as the industry.
Okay, so that should have given you some idea about what the Cal Poly packaging program is about. Now we are going to step into some of the labs, and I'll show you some of the equipments that you will get to use if you were to be in a classroom or a lab environment learning a particular subject matter. So to start off, what I usually let students know is if you were to do a bachelor's in industrial technology and packaging with a packaging concentration or packaging minor, the student will be able to design, develop, and validate a packaging solution for the global supply chain. So that's the objective of a student pursuing a degree in BSITP with a packaging concentration, as well as someone is pursuing a packaging minor with a bachelor's in food science, say. So bearing that in mind, let's step into our first lab. Our first lab where is primarily related to polymer processing and packaging. So this piece of equipment right here, which you see, is a thermoforming equipment. And right at the bottom here, you see a mold. And this mold, you'll be, as the video runs, you will see a sheet of plastic takes the shape of this mold. And there are several packages which uses this format. You can think of some of the hardware goods, some of the consumer electronic goods are using such kind of packaging. So the sheet is heated up first as it was pushed in. Once the sheet is heated up, it is pulled out and it will come out in a bit. So just bear with me. So once the sheet is pulled out, a vacuum will be pulled to form around this mold, and it will and the sheet will take the shape of this mold. So it should be appearing right now. So the mold is pulled up, and now there is a very good draw. The sheet forms nicely around the mold. So as part of your education, you will learn the different types of materials that are used to create such thermoforms, and not always all type of sheets is usable to make a thermoform container. Another piece of equipment which is in the material testing, lab. So once you have, say, developed a package in the polymers lab, you have developed a material in the polymers lab, or you have developed some paper-based substrate in that lab, you want to be testing it for its strength. So this equipment right here is your tensile tester, which is going to find out how much force it takes to rip apart 2 layers of corrugated board which are adhesives together. So this is important in relation to how a box may perform if it were to experience any kind of bulging or compression related force. So let's take a look. If you observe very closely, you would see that there would be a sudden jerk when the corrugated board separates from each other. It's barely visible, but it is very, very quickly it changes. So it should happen anytime now. There you go. You saw this sudden jerk. So that's when the equipment stops and it tells you how much force it took to break that adhesive area. And which, so the students not only perform this exercise, but they also collect data and run calculations to find out the pound per square inch it took to break that, and then make inferences based on the lab activity. This slide right here is showing how you prepare samples for tensile testing for polymer materials. So this is Dr. Shin right here. He's preparing samples for which will be used for tensile testing. So let's take a look at how one prepares samples. So he's taking a polymer film right there, and the intent is to create those strips. And these strips, the dimension of these strips, what he's measuring there is the thickness of the strip. And the sample cutting procedure and sample preparation procedures are as per ASTM standards. So these are standards which you will learn about again in the class. So one has to prepare samples as per the ASTM protocol guidelines, and then once you have prepared these samples, you will introduce them into a tensile tester. So just like the previous tensile tester, we have another tensile tester which is primarily used for teaching purposes. So the film is put in between the jaws, The jaws are, as you can see, Dr. Shin is placing it in between the jaws, and the upper jaw is going to get clamped first, and then the lower jaw, once he has uh, stretched it out properly without any curls in it, it's clamped, which he has clamped. And now you will notice that he will do a close-up, and he will start the equipment, and you would barely see the jaws moving, but if you pay close attention, you just might be able to see that the jaws are moving. In continuation, as the jaws are moving, you will see a plotted line right here. So on the x-axis is deflection, that's the distance, and on y-axis is your force. So you can see at this time the jaw is moving upwards, stretching the film, and the intention is to find out how much force it takes before the film breaks or ruptures. That again tells us the property of film, as well as you can make sense of how much it would take for, say, for instance, a grocery bag to fail before fail at a certain amount of force per square inch. Now we step into our packaging dynamics and distribution lab. So say you have created a packaging material, paper or plastic, you have converted it into a package. And the package could be a bottle, could be a bag, could be a box. In this case, what you are seeing here, it's multiple number of bottles which have been unitized by a shrink wrap, around say 24 bottles, and each of these shrink wrap bottles have been put on a pallet. Now the pallet load needs to be secured with a stretch wrapper with stretch wrapping film in order to be transported. So if a product package system does not arrive at its location, that is an end user, it could be a retailer or it could be a warehouse, then the product package system is a failure. So before you send it out into the field and transporting your product package system to its end user, it needs to be tested in a distribution lab to ensure that it would survive the trip. So what you're going to see here is a stretch wrapping equipment which has different settings. All palletized loads cannot be stretch wrapped the same way. They have different kind of films can be used, how much to wrap, the thickness of the film, so on and so forth. So these kind of details is what you will be learning in a course, and which is related to packaging dynamics and distribution, and it is being the lab portion of it is done in this lab right here. So let me start the video. So what you see here is it starts wrapping it from the bottom. It does a couple of wraps at the bottom, and then it goes up all the way. It'll do a couple of wraps at the top, and then it's going to come down all the way, and it should stop by itself. So now you may see this right about, let it turn a little bit. I'm going to reverse it a little bit and pause so that you can see what I want to show you. Maybe a little more. And right here. So what you see here where my mouse is moving around are load cells. So there are load cells added at the top tier, middle tier, and bottom tier. So the objective of this exercise was to find out what is the containment force of this stretch wrap material around the palletized load. So this is to find out how much force should we be using in wrapping a palletized load so that it does not fail in the field. So one may ask, how do you know if it will work or not? So I'm going to move on to the next slide. So here is a vibration table right here. So the vibration table, what you see here is loaded with reusable plastic containers with broccoli heads. So broccoli florets. So one way to test if a stretch wrap is going to work or not is to place it onto a vibration table here, and you will understand in a bit after you watch the video how a vibration table may impact the product packaging system. In this case, we're going to look at broccoli, and then we'll look at another video where we will be truly testing the stretch wraps capabilities. So let's look at these two videos. We're going to look at two videos here. So to give you an essence of what's going on here. So produce, and not only produce, but any kind of product which has been packaged will face different levels of abuse if it were at the bottom layer of a palletized load, say if it was at the bottom there, as opposed to the top here. So in this, these two pictures right here, what you see are basically broccoli florets packaged in different kinds of films, and as opposed to the control, which is if it were to merely be put into a reusable plastic container. So what we wanted to see is which packaging system is performing the best, as well as we wanted to see if does it really matter how the abuse is at layer 1, that is the bottom layer, and how it is at the top layer. So in the next, in these two videos, I want to draw your attention to how the florets are bouncing around and how they may get abused, because we know that due to vibration forces, these florets are going to be experiencing physical abuse, which will tend to break the cell walls and thereby increase food degradation. So if you look at the right, if you look at the left, it's the florets are the vibrational force on the florets are relatively less at layer 1, as opposed to when you look at on the right, which is on the layer 6. So it tells us that there is a high possibility that when we conduct experiments and and collect data, it can be indicative that the broccoli, which was transported at the upper layers, could face more abuse than the ones with the bottom. So in this case, this was bulk packaged, and these are broccoli florets. And usually broccoli florets will not be shipped like this in an RPC container, but this is the control, and that's what we were trying to compare against the control with the different bulk packaging systems, which you saw in this slide here. These are basically big polyethylene bags with different kind of packaging technologies in them. Now, it brings us to the inclined impact test. A couple of slides ago, you saw how we stretch wrap water bottles, and we used another stretch wrapper to stretch wrap the water bottles, and we conducted a test. This was a senior project done several years ago to gauge how well the stretch wrap is working on different types of pallet patterns, and pallet patterns will become clear. I will pause as I move ahead through this video. So this is the unit load stability evaluation inclined impact test. So I'm going to pause here a bit. So what these letters mean here, that first of all, there are 1, 2, 3, 4, 5, 6 layers. There are 6 layers of water bottle. The first 2 layers have been arranged in the same pattern. Then the next 2 layers have been arranged in an alternate pattern. And then again, the top 2 layers are in the same palette pattern as the first 2 layers. So what by palette pattern does one mean? It is the way the bottles have been arranged on a layer as you go from the bottom all the way on the top. So the first two layers are, you have the bottles in the same, on top of each other in the same way, whereas the second two layers, if the bottles have been arranged differently as opposed to the top two, which are the same as the bottom. Now this full unitized load is going to impact against a backstop, and this backstop right here is going to prevent it from it keeling over. But what it is essentially simulating is if this if this unitized load was in a truck and the truck was braking or turning a corner very sharply at a high speed, then what is the likelihood of this stretch wrap material to completely unitize and keep the load from keeling over? So the study was twofold. One was to see the performance of stretch wrap uh, affected by the different pallet patterns. So you do several impacts to find out how the unitized load is performing. So let's continue with the video. So this will be the second impact. The students have basically turned the pallet around. So you impacted on the short phase, impacted on the long phase, then again you impact on another short phase, and then again on the long phase. So this is the third impact. So now the pallet has keeled over slightly, but it is still unitized. And this is the fourth impact. And it will more than likely be okay. So it tells us that the stretch wrap equipment worked well along with the pallet pattern AA, BB, AA. Now let's see how it would perform if the first four layers are the same pattern and the top two layers are different pattern. So the first pattern that we looked at is known as the interlocking pattern, as this is more of a column kind because four layers are the same and the top two are different. So it's kind of interlock, but it's mostly column stacking. So here is the first impact on a broad face. It should run in a bit. So the speed at which that platform moves is also part of the standard. So as you can see, it keeled over relatively a lot more than your previous. And this impact right here would render the unitized load unsafe and not good for transportation. So what it tells us here is the pallet pattern AAABB is not suitable for transportation. So regardless of what stretch wrap you use, it is more than likely going to fail. Yes, you can use a lot more stretch wrap. You can wrap a lot more stretch wrap around it, but then again, you'll be increasing the cost of this whole unitized load. So stretch wrap material, even though it's not expensive, but if you are stretch wrapping thousands of these unitized load, then they eventually add up. Even a savings of penny in the packaging industry goes towards a lot of savings. So this should give you an idea of what one does in the packaging dynamics lab and how does it relate to all the other labs that I was discussing about in the earlier slide. Which brings us to packaging minor. What is the benefit of you doing packaging minor? As you would have noticed, I myself had food science, have a food science background from my master's degree. During my food science education, my thesis was related to shelf study, and I found out that that one of my experiments was giving me wrong data because I did not store the peanuts that I was studying in gas flushed glass container. Rather, I kept them in gas flushed Ziploc containers. So I had some erroneous data, which I corrected and amended accordingly, but it got me thinking about how packaging can play a role, and I started investigating about if there is such a discipline. And I found a discipline at Michigan State, and I continued my education. So that brings us to packaging minor. Having a food science background, once you have had a degree in Bachelor in Food Science, you should find it of a lot of benefit when you are approaching a lot of the companies that you would like to possibly work for. So, so I'm showing you this slide right here is we have a packaging specific career fair every winter quarter. That is, it happens in the third week of February. So usually the career fair takes place at the UU, the University Union, or at the MAC, which is at the Rec Center. So these are companies which usually have been coming to recruit our students. Some of the companies you may recognize, it's food related: Shandon, Kellogg's, Wonderful Citrus, Ruiz, Wonderful Pistachios, Taste Selections, PepsiCo, EJ & Gallo, Keurig. So these are all companies which are food specific. In addition, there are companies who are packaging material suppliers like WestRock. Then you have All American Containers, Dow Chemical Company. So all these companies are looking for students, are looking for professionals who do have a background in not only food, but packaging as well. And in addition, it increases your competitiveness and compared to students from other universities who do not have the opportunity to learn about packaging. So it increases your competitiveness against your peers from other universities, and it gives you a lot more knowledge from a food science and packaging point of view. So how should one go about it? So I'm going to come to it in a bit. So here is a couple of pictures. As you can see, our career fairs are not as dense as the university career fairs are usually. We typically have about 28 to 32 companies visit. We have about 90 or about I would say 100, about close to 100 students go through the career fair, and these are mostly students from industrial technology and packaging, food science, and from graphic communication. So it's less intimidating compared to your university career fair, and you get the most out of it by attending this career fair. So what is it that you need to do for your packaging minor? So I'm going to highlight some of the courses that you will need to take as part of your required courses and part of your elective courses. So electives, I'm going to suggest what you can take, and required, I'll indicate what you usually would take, but you might need to get it substituted. So for example, we require Chem 110, Chem 110. And by the way, I'm the packaging minor advisor, but food science students take Chem 127, so you merely have to get it substituted. Then you take FSN 334 as food packaging, which is the required course in food science. This usually is offered in spring quarter, and I believe you take it in your junior year. So that course meets this requirement. Then you have to take Physics 121. Which is your college physics. And you have to take ITP 330, which is one of the required courses for packaging. You can take this in a junior year if you have junior standing. The sooner you take this course, better it is, because this course is a prereq to a lot of our 400 level courses in our elective. In the elective, the courses that I recommend for food packaging, food science students is packaging polymers and processing, 340 ITP 341. That's where you will learn about polymer packaging. Then I recommend packaging machinery and processes. You learn about food processing in food science. Then what happens once the food is processed, it goes into the packaging machinery and processes. And that's you basically are linking food processing with packaging processes, sorry. And then there are multiple other courses which you can take from rest of the list, but the ones that I recommend are, you just need 3 courses from here. You could either do packaging sustainability, instrumental analysis of packaging polymers. You learn about how different instruments are used to characterize different specifically packaging polymers, but the analysis methods that you learn can be utilized for other packaging materials as well. Another course I recommend is packaging laws and regulations. So if you like foods law and regulation, then this is a course which I would recommend for those of you who are interested in food safety, food laws, so on and so forth. So how will you go about? So first thing first here, so I would want you to click on this packaging miner application process, and in it you will see that you have instructions in downloading the form, which is on the form right here on the right hand side, and you go through the form, select the courses that you would like to take, and then you schedule an appointment with me, or you come to my office hours. This is the most easiest way of meeting with me. My office hours on Tuesday, Wednesday, Thursday, and it's always 10 to 11, and you merely have to click on this link and I will let you into my room. So every Tuesday, Wednesday, and Thursday from 10 to 11, I'm in my room. So during the meeting, you will need to bring this form with you virtually, and we will go over the form together, identify and confirm the courses you are taking, and then I will send you an Adobe Sign link, and you will fill up the form in front of me. You'll sign off, and I'll approve it, and it will be sent to your registrar office. So that's all I have. If you have questions, please do email me. And I hope this was informative for you, and I look forward to seeing you if you would like to pursue packaging minor. Thank you.